Hey guys, hopefully everything is working. I've never done a stream before. So let me know please if you can hear the audio and everything looks okay. Hopefully it does. But in the meantime, here. Okay, so this is going to be the second part of the, yes. Okay, awesome. So yeah, this is going to be the second part of the environmental tester video. The first part was doing the schematic, which I have up here. Sweet. Okay, yeah, so it looks like everyone can hear. So yeah, I'll just do a quick recap on the project overall and then what the schematic is. So it is going to be based on 4D Systems touchscreen, which has a ribbon cable which can communicate over SPI, I2C, UART, and then just general I/O pins. So that will be the main human interface for the board. The board will take in a 5-volt signal, I believe. Yeah, 5-volt in on the connector, go into a buck converter, drop it down to 3v3. The 3v3 will be used for a humidity and temperature sensor and a onboard microcontroller. The microcontroller is a ESP32. So the ESP32 will have a Wi-Fi and Bluetooth radio. The Wi-Fi will connect to our server's internet so we can view it remotely. And then, of course, the interface for the touchscreen. And I believe this is pretty much the same as when I did the schematic a while ago. I did change the polyfuse to a little bit smaller value, and I changed the touchscreens to a standard fuse, not a polyfuse, just to save size. Some of those polyfuses are massive. Like I think this was like an 1812 before, and now it's a 0603. But yeah, that's pretty much everything with the schematic. And what I did already on the layout. So hopefully you can see on the back side of the touchscreen, there's a little recessed area for a circuit board to slot into. There was no possible reason we needed to use that entire space. So what I did is I'm planning on having the PCB essentially just slot right there, and then the ribbon cable slide in. So that is essentially what I have modeled here. So this is widthwise. This is where the cutout for the recessed for the PCB will nest to. So the keep out area is going to be hanging off the edge right here. And the key with that is, since it's a RF antenna, you have to make sure to not have any metal behind it or in front of it, which as long as it's sticking out from here, it'll only have that plastic shroud. It's still not ideal, but it's about as good as we can do. And the ribbon cable is just centered not to here. It's centered where the connector on the screen is. Oh, thanks, Joey. I appreciate it. So before getting started on any layout, first, obviously, you have to figure out what the stack up is going to be, how many layers. This probably could be, or not probably, this definitely could be a 2-layer board. But since it's so small, and I don't think I've done any multi-layer boards on here before, or if not a full layout. So I definitely want to do this on a 4-layer. So what I am doing is, it's kind of a different stack up than most people do on a 4-layer board. Typically you will see signal on the outer layer, and then a power plane on the inner top, and a ground on the inner bottom, and then signal on the bottom. What I am going to do on this one is make the top a signal and power layer, the bottom a signal and a power layer, and then make the two inner solely ground. So that has a couple big advantages. One, it makes sure no matter which layer you are routing on, whether you're on the top or the bottom, you're always going to have an adjacent reference plane that's ground. You can get away with having a reference plane that is power, so 5 volt or 3v3, and that's totally fine for high frequency signals, but for DC, it's not ground. So your returns will have to go back on another layer. So by making the inner two layers ground, you always have an adjacent ground reference. The second thing it does is, since your power, so your 5 volt or 3v3, is always going to be on the top or bottom, you will always have a close coupling of your two power planes. So 5 volt to ground and then 5 volt to ground. That's one of the other keys with a good stack up, is you want to have what's called close coupling between power and ground. So this 4-layer stack up does all of that. You could make it a little better by, instead, you put the ground on the top and the ground on the bottom, and then power and signal in the inner. But that becomes a pain to route because every one of your signal traces has to go straight to a via, which it can become a pain. And then also going to rework, you have to rework on an inner layer, which isn't very pleasant. So that's what the stack up I will stick with here. And I think that's pretty much all the background. So typically, first thing I will start with is doing ground pours, and I will put a ground pour for this on every layer. And thermals, you can either do you can either start the ground pours without thermals or with, because I always change that at the end anyway. This one I'll just do them with. And another thing with this stack up, and kind of any stack up in general, is if you want to put ground on all of your layers, even the ones which aren't necessarily a ground pour, I virtually always do. There's a couple schools of thought with it. The main issue is if you have controlled impedance lines on a layer that has ground everywhere, it's going to throw it off, because you can't have a true controlled impedance when you have ground on either side, because it's going to throw off all of your matched lines. This doesn't have that, and even if it did, all we have to do is just do a peel back from it. So I typically will start it with ground on everything. 1.5, I don't know exactly which, 5 or 5.15. I'm using the KiCad 5.99 sometimes, but I still try to only use the actual released versions until it's officially supported. So pours are on there. Makes it cleaner when you put on anything with ground. Instead of seeing your ground rat's nest everywhere, those will be able to make a bond with the ground plane, which just makes it a little bit neater. So first thing, I like to sometimes get some of the bigger components out of the way. So this, I purposefully lowered it when I did this earlier to make sure I could fit the tag connect programmer over here. Doesn't really matter where that goes. Buzzer is pretty big. I don't think it really matters where. Maybe over here. And then I guess the power connector. So the power connector I'm using is just a generic, like 2.54 millimeter surface mount. I might change that or just use a little micro USB. Haven't really figured that out yet. And I will try, that'll be kind of a pain. Trying to figure out how to set everything up so I'm not looking away from the camera. But I guess to look at the schematic, there's not a whole lot of choice. So next, on most boards that don't have a lot of high-speed signals, you typically want to start with the power section, especially if it's a switching supply, which this obviously is. So the key with your switcher, it really doesn't matter how close it is to your input supply. What matters is that all of the routes for the inductor, the input caps, everything are close to the regulator itself, because none of the signals or none of the power going from the main connector to the switching regulator are going to have fast rise times as long as you filter it on the input side. So it's based from the regulator itself. And something that I really like to do is pull up the data sheet to see what their recommended layout is. It doesn't matter how good you are or how comfortable you get with laying out boards. If you are not, 1 second. If you are not paying attention to the reference designs that companies will give you, you are spending a lot more time than you should. They're the ones who develop it. They typically will have the best information on it, and it just saves time. So with here, you can see on the top layer, they are feeding the ground side from the input through the center of the regulator, and then having the input side right there. So this seems like a pretty well laid out regulator. When they allow you to do stuff like that, it makes it pretty easy. Man, I use those tag connects for everything. They're actually a lot more common in industry than you would think. I see them in a lot of production designs. What's cool about them is you can get them with the legged version like this. I don't have any around. So the legs grab in and stick. So this is really good for like prototyping. You can just plug it in and leave it. But they also make them without the legs. So none of this section is required. And it just is this small little area. So yeah, those things are amazing. I use them on virtually every design that has a programming section. So now, going with the input regulator, or the input side of the regulator, what I will do is grab all of the capacitors on the input side that are with that block and group them all right by the chip. And there's quite a few. Oh, already grabbed that one. And one thing I'm going to do in a video coming up, I'm just figuring out the best way to be able to like quantitatively show it, is something I've spent a lot of time figuring out and doing a lot of simulations and reading a lot of books, is there's two schools of thoughts with decoupling caps, and somebody actually on a video a while ago pointed it out to me, and I really appreciate that he did. And basically the school of thought is whether or not you should use all capacitors, and this is for decoupling for IC pins and for the input of like a switching supply like this, is you can either use all different values, so 100 nanofarad, 10 nanofarad, 1 microfarad, 10 microfarad of either the same package size or different package size. The other school of thought is if you should use all identical values with as small of package size as you can. And Traditionally, you used to see almost everybody do the different decades, and that's what I have traditionally done. So I would typically start with 10 nanofarad, 100 nanofarad, and then 1 or 10 microfarad. But the issue with that is you can get what are called anti-resonance peaks, and it's where the impedance lines cross, and you can actually get a really big resonance peak. Typically, it's damped because on the board there's a lot of parasitics, but you can still have a really big issue with that. And I've been doing a lot of simulating on Spice, and I'm just trying to figure out a really good real-world example of how to show it. But I am looking forward to doing that video because I have learned a lot recently doing some simulations. Control T to snap the component. Seriously? Wait. Yeah, but it doesn't work from the schematic side. If I click from the schematic, I still have to click over here to then be able to Control T. No, that doesn't work. Maybe I'm doing something wrong. I wish it did that. That's one really annoying thing, is going from the schematic to the layout. Okay. Oh, Control R. Control R is rotate. Okay. So on the regulator, the most important thing to get sorted first is the input cap side. And since for this layout, or this schematic, I am doing, like I said, the different decades. So I gotta figure out an easier way to do showing you guys the schematic with 2 monitors. So first I have the 1000 picofarad, then it goes to 0.1 microfarad, then 2 10s. So the other school of thought, since these are 0603s, you would get the biggest 0603 capacitance you could get, which at this voltage would probably be a 4.7 mic. So you'd have 2 4.7 mics here, and then your 2 10 mics there. But again, I won't get into that too much. So, and I always route my start of the layout with small traces like this, just to get an overall idea of where everything will be, and then I come back in after the fact and kind of clean it up and use the actual size traces that I will. And same with pores. It just takes way too long if you're trying to do the pores at the start, and you're inevitably going to have to change things. So that typically doesn't make a lot of sense. So the input side is routed, and comparing the loop area is about as small as you could do. Obviously, if you had power planes, you could tap into your power plane here and then into your reference, which we will do the reference plane on all the top side components, but I typically do that after. So the next thing on a switcher is to do the inductor. And here for the inductor, they just put it right outside the switching pin. This does have a Bootstrap cap, I believe, yes. So they're tying it with this via, it looks like. Yeah. So they tie it with this via over to here, where the Bootstrap cap and then the current limiting resistor is. So if we grab our inductor right here, and I've been using these, oh no, this isn't it, never mind. There's a really cool, oh yeah, it is, the 108 footprint size inductor. I've been using these a lot, and they are really convenient to route with because of how small they are compared to the bigger unshielded inductors. So here we can put just pretty close to being aligned here and connect with our trace. So this is what's called the SW node, the switching node, and it is pretty much the noisiest node on the output side because it's going directly to your inductor, which is obviously smoothing your voltage. So this side, you have to be really careful that no sensitive traces go under. Same with the 5-volt side a little bit, but it is smoothed by the capacitors. So it's really this node right here you want to be really careful with. So then for our Bootstrap, they were putting it, oh no, this is our enable pin. Enable, we do that at the end because that is one of the least important, or that is probably the least important node. So after the input's routed, the inductor gets placed, and now we worry about the Bootstrap. So grab both of these, and then so they put them on the other side with the resistor here. So they did something like this, I believe. Oh, wait. Oh, wrong one. And one thing that made me kind of excited about doing these live streams like this is, and I am certainly not the best at layout. I think I'm much better at the schematic side. But even people who are really good, like our layout guy at work, he is the most incredible like artist with some of this stuff. And it's always like intimidating. If you look at like a finished board, it sometimes makes you intimidated, like, oh my gosh, how in the world did they lay that out? But in reality, if you watch people, like I'm sure you'll see with this live stream, the boards come out like pretty terrible the first time over. And it's basically just like a iterative process. You place everything, do your routes, and you're gonna see like half of them do not make sense. So then you just go ahead and start changing the ones that don't make sense, and then you do it 2-3 times in a row, and it starts to actually look decent. So hopefully this shows that even if it's a hard layout, if you just put the time in, it becomes a lot less scary. And don't ever expect to have a layout turn out great your first time, because unless you're way better than me, that's probably not going to happen. Okay, so our Bootstrap, and I know they put this on the bottom side. I'm assuming there's a reason for that. I don't see it right off the top of my head, but I'm sure there will be a reason for that. So now on the output side, there are obviously the output bulk and decoupling caps, and then also the feedback node. These, either one, the feedback node's not important in and of itself unless you screw it up. Screwing it up is basically if you take the feedback node and you drop it up under that switching node, there is going to be a ton of noise that gets coupled from the switching node into the feedback, and your control loop on the output side can be really noisy. So as long as you don't do that, it doesn't matter if it's long, because it's not carrying any current, and it's a slow speed node. So as long as it's quiet, that's all that really matters. So now for the outputs, these are the that's the feedback side, and then these are the capacitors. Trying to figure out now where it makes sense. So 5 volts we can have come in here, 3v3 outputs to the ESP across a ferrite, and then the humidity sensor. So it really doesn't matter. What I think I'm going to do is the input filter first. So the input filter has the input fuse a Zener or TVS diode, same thing, to make sure any transients get clamped, some capacitance in and out, and then a common mode choke. Common mode choke for a board like this, primarily make sure that any high frequency common mode noise from the ESP doesn't go onto the cable. And if common mode noise gets onto the cable, you have an antenna, and that's where you can get a lot of EMC issues. So it's pretty much universally a good idea to have a common mode choke on any design, especially if you have a long cable. But even if not, it still helps. So here we'll do the fuse. And I might have to redo and move those. I don't think I'm going to have enough room to keep all the caps in a line. I might have to rotate these 90 degrees. So next we go to our Zener. And Zener, TVS, they're pretty much the same. TVS diodes will trigger a lot faster, but they usually don't have a peak current rating or a peak power rating. But as long as you get a beefy enough TVS diode, they're essentially the same thing. So on input filtering and stuff, I'll typically use a TVS over anything else. So yeah, we're definitely gonna run out of room. So I'll at least grab everything over here. Get the regulator out of the way, because this side I don't think there's going to be a lot of options to change how it's set up. Where the regulator, we can just shoot it up here a little bit. And then 2 caps. And I would say probably this is quite overkill for such a simple design. It is, but it isn't, because that ESP does have a pretty high clock, so there is going to be a lot of switching noise, same with the regulator. So it's always good to throw some extra filtering. The biggest thing with a common mode choke, but even more so with a ferrite, is you have to make sure that there's a lot of capacitance on the downstream side, or else you're essentially going to starve the rest of the circuit, because it's not going to be able to get any power because the ferrite blocks it, which is what you want. But if you starve the rest of your circuit, you're going to be making it worse. So ferrites are great, but you do have to be careful with them. So we could maybe put it down here, because I remember from previous times, yeah, pin 2 is the 3v3 for the ESP. So I was trying to keep it outputting down low, but I guess that really doesn't matter. So maybe what we do is delete this trace. We can delete these two. And take this and then rotate it here. This will increase our loop area a little bit, but it's on our 10 mic caps, so it shouldn't be a major deal. And as long as we route input side here, I think that's okay. So now we can tuck this in, and maybe let's move all of these down as well, so that gives us more room on the top side. Okay, so now you can place D1 below F1. Ah, see? There's another reason I wanted to do a live stream. Can save me. Good call. Yeah, so we can definitely tuck this up under here, and that will save a lot of space. But see, again, that goes to show my point. There is always going to be things that you miss. Oh, actually, wait, that makes our decoupling cap. Yeah, but I still like that better. It just makes our route here a little bit. So this might be a spot where using a pour might help later on. But yeah, that's still fine. I like that better than how I had it at first. Okay, and again, remember the first time, and some people try to do it really good at the start, but I like just throwing on traces and making it as quick as possible and then come back and clean it up. So I don't really have to care about how good the routing looks on the first go. So we still wouldn't have enough space to do it how I originally laid it out. So I think that works fine for now. So there's our input side. 5 volts just goes to here, and then our touchscreen has a 5 volt. So 5 volt we can route. So one issue is we don't have a good escape from the 5 volt trace here unless we go to the bottom, which I guess that's fine. We can just escape out to the bottom and then hit 5 volts here and there. That's another really good thing about this stack up. Since you have 2 dedicated ground layers, you do not have to worry about jumping from the top to the bottom often. Since you always have your ground reference, it doesn't matter. Whereas if you were doing signal, power, ground, signal, that makes it so you kind of want to stay in one layer as much as possible, or you jump layers. Your reference jumps. So now we can put our output side. Got an international audience, it looks like. Hopefully the weather is nice. I know there's a lot of really bad storms up in the northeast of the US. Here in Florida, it's like 75 out, I think. Incredibly humid. Okay, so there's our output caps right here, and now our feedback node. So like I said with the feedback, all you worry about that is keeping the traces from going over a noisy node. So here, the common node that is always an issue, and it will cause issues if it gets close to it, is this switching node. And by default, the Bootstrap node can be noisy. So what I think I'm going to do is go against the reference for now and put this here. And what this will allow is keeping the Bootstrap node away from where I'm going to route the feedback side. I think that works pretty well. So we can tuck this in here, the ground side of the divider, and then grab 3v3, grab the center point, and then take this over here. So again, it doesn't matter how long it is. All it matters is it stays away from anything noisy. Clean that up. And the last thing is the enable pin, and I don't know why it just has a capacitor. I'm guessing that's what the reference, it wants it to float if it is always going to be on. I don't know why component IC manufacturers do that, unless it has a weak internal pull-up, or I'm wrong when I did it. Because normally this would be pulled up instead of just a cap. The cap keeps it from resetting, presumably. So that is the crucial part of the board done. So from here, I will probably go and work on the ESP circuitry for now. It doesn't really matter. And one thing I did notice when I was getting ready for this, the environmental sensor, they want it to stay like, they don't want any heat from the rest of the board interfering with this, which I guess makes sense. So ideally they want it to have like a moat around it so no heat gets transferred from the rest of the board. I don't know if we're gonna have enough space. Maybe we put it up here. So yeah, maybe let's just plan on keeping this area without anything and work on that a little bit later. But for now, yeah, let's do the input side of the ESP. Absolutely, and that's talking about if you can trust the references from the data sheet. No, totally, they will lead you astray, but they definitely will get you on the right track a lot faster, because if you're dealing with a buck converter like this has, really if you keep the input loop small and you don't get anything over the feedback node, it's probably going to work pretty well, because those are really the vast majority of the time that's what causes your issues. So it's just easy. You look at the reference layout, and if they are sacrificing this loop right here for another part, you know it's wrong, because this is the most crucial loop. With following their reference on this one, it's about as small as you can get. I do think, actually, looking at this again, I'm going to go back to how I had it before, because then we don't have to go on the bottom layer to break this out. So now we can just tap into our 5 volts directly and go just up here. So I think that probably makes more sense. But yeah, Rick Hartley, he's pretty much the man when it comes to a lot of signal integrity. Him, and I've been reading a lot of, or Hartley really doesn't have a lot of written work, which is kind of a bummer, but he does have obviously a lot of the live streams with Altium. So his stuff is really good. Obviously Henry Ott and Howard Johnson are really good. One thing I actually have noticed lately, and it's really weird to say, because kind of when I was learning all of this, Henry Ott would always be the person like who would be my go-to reference in this stuff. A lot of the stuff with his, especially as of late, seems to be a little bit outdated, whereas Hartley has kind of stayed up to date on it. Same with Johnson. So I kind of have been using them as like the go-to references, especially with stack-ups. Rick Hartley and Henry Ott, they have very different opinions on stack-up. Hartley makes sure it's power ground next to each other over anything with no signal layers in between, where Henry Ott, that's important to him, but a lot of the stack-ups he has will be power, signal, ground reference, or power, signal, reference. So it just shows you there's a lot of different ways out there to do the same stuff. So I think I'm going to make the board a little bit wider. That's making it really tight to even be able to fit a single cap on there. It'll only add a couple bucks, especially ordering it from China. Oh, but Chinese New Year, that will make ordering a little bit more fun. Okay, so now we can fit 2 here, here, and ground, and then 1 mic is there, 10,000 peak. So actually, I guess this one should be here. And since I'm doing the decades approach for the caps, the important thing with that is to make sure, obviously, your smallest value is closer to the IC, and then just build up from there. I have a trace there? Yeah. Okay, now the ferrite here, and then I have the big 10 microfarad with a dampening cap, which that part is probably overkill, but it helps avoid some of the oscillations and the ringing like I was talking about earlier, because it essentially just damps the response of your damps the inrush of the current. Okay, yeah, this is, I do not have much room down here. So yeah, I might have to make this a little bit wider. Okay, so okay, so here okay, so we have pretty close decoupling here, and then our bigger ceramics are a little bit farther away. Apparently I said okay, G-O-O-G-L-E. And then our ferrite to our input cap. So that's certainly not ideal. I don't really like how that is, but unless I want to make the board a lot wider, I don't think there's a huge option. Have no idea what you're asking. I one click over the pad, gets locked, but that won't end the routing. No idea what you're talking about. The biggest thing that I found, took me a while to figure it out, is the high contrast and normal contrast. It makes it so it only lets you select whichever layer you're on. It is amazing. But KiCad 6 lets you dim the layers you don't want to access, so it kind of makes that side pretty easy also, so either or. Okay, so now the ESP power supply is handled. Now I guess we can do some of the 40 systems. There's not a whole lot here. One really annoying thing that 40 systems does is they do not space grounds well at all. So your return current on this trace, you have all these signals sharing 2 grounds on either side. You're gonna have a lot of noise in this. I guess they get away with it because nothing's super high speed, but ideally the grounds would have been spaced out more, and the ideal situation is you would have made this connector like 5 pins more and then just throw in some grounds here, but I don't know why they didn't. And now 2 decoupling caps here. And our fuse. And my rule of thumb basically is anything that leaves the board is going to get a fuse, whether it's a slow blow, a poly fuse, or what, or an electronic fuse. So if you have some crowbar, you have some way to limit it logically without having an actual fuse, that's fine, but it has to have some sort of limit just because that's where your danger points are, especially protecting the traces on here because they're going to be a lot smaller than your main input supply wiring. Oh, and one thing I see a lot of people do, and if I'm not paying attention, certainly I will sometimes, is, oh gosh, hope KiCad can fix pad entrances one day. Never do this. If you have 2 traces that connect, don't route over. It goes against the IPC standards, and the main reason is when you go to assemble that board, there most likely won't be solder mask there. So every time it reflows, you're gonna get either a bridge or what looks like a bridge. And then when the assembly house goes to inspect it, it will fail every inspection, even though it's logically correct. Not that it makes a functional difference, but you want to keep IPC happy. Okay, so that is the TVS diode for the I2C, our input decoupling for the 4D systems. Explain D2. Yeah, super important and pretty easy once you understand it. So basically there's a very good chance, so your user is using this, they're touching it with their grubby hands. This is a plastic surface, so in theory you shouldn't get any static going to the back, but maybe it's on a plastic enclosure, maybe there's a little crack in here, whatever, and you happen to get static on here. The 4D systems we didn't design, obviously, we have no control over it, so if something on here gets fried, nothing we can do. But what we can do is if static gets coupled to our cable and goes down it, that we can control. So basically, TVS diode, if that voltage spike comes on these two pins, if it's higher than your rail voltage and higher than whatever your TVS diode clamps it to, it reverse biases and shunts it to ground. If it's a negative voltage spike, and again, voltage is relative to ground, so if it's a negative voltage in respect to your ground, it just goes across your diode forward and dissipates it. Obviously, that energy is still going into your ground and your power rail, so anything else on your board could be affected, but due to all the bulk capacitance you have on the rest of your system, it has a much better chance of surviving on your power rail than if it goes on your SCL or SDA pins and goes straight into your ESP. If your ESP takes a 2000 volt spike, probably isn't going to make out so well. But yeah, good question. That's another thing. Any inputs that come from the outside world have to be protected when I do a layout. Just because it's cheap protection. I mean, these things are super inexpensive. My educational background. Ironically, absolutely nothing to do with electronics. My degree's in mechanical engineering. When I was growing up, I did a ton of electronics work. I volunteered at I took classes at and then volunteered at a science center near where I lived. And then while in school, I did a lot of research, like undergraduate research for a bio lab, but there was a lot of like electrical work with it that I did a bunch in. And I was in a rocketry club where I was the head of the electronics side of it. And I've always just enjoyed electronics more than mechanical, ironically. I learned KiCad when KiCad 5 came out, because before that I used Eagle, and then when I switched to KiCad, never went back to Eagle. Oh, and that's what the other question was. Yeah, Eagle, especially when it went to Autodesk, I am not a fan whatsoever. But that's cool, you get to use Cadence. It's a shame how they push Cadence so much at expense of OrCAD, because OrCAD's basically just left to die, where Cadence is where they put all their time into. So that is a terrible route. That's what I get for talking. Maybe this should rotate. I'll come back to that. Okay, so now we have this reset switch. Maybe get rid of the reset switch. I don't think we'll end up needing it. I'm not sure. And then here's our photodiode. So from here, so now is where you have to figure out on a multi-layer board, you typically do north and south on one layer and east and west on the other. And it just makes it a lot easier. Both routing is easier that way, and it also makes sure that you don't have traces on top of one another that can couple and interfere with each other. So if they're just crisscrossing, it's a lot shorter of a distance that they have to that they're going to be over one another. So I guess what we can start with here, I'm just looking at the schematic. I guess it really doesn't matter. Maybe let's start with doing the signals from the ESP to the 4D system. So they're over here. What I think I am going to do is do bottom layer north and south and top east and west. It could change, but I think that makes the most sense. And obviously that is not set in stone. You can always change it. Yeah, you can skip the clip-in one, but then when you go to program it and you're testing it, if you want to like debug it, you have to hold your hand on it the entire time, which is an absolute pain. Production stuff, absolutely, we'll use the no clipped one, but for programming, no, I definitely like this one better. And of course, those just so happen to be on the opposite side, as always, but that's fine. Okay, so now our I squared C is mostly routed. But yeah, that's a good point. Wait till KiCad 6 comes out. I agree with that. Not that you're going to have to relearn much from KiCad 5 to 6. It's still pretty much the same. It's not like going from 4 to 5, but yeah, that probably makes sense. Why have to spend time doing both? Okay, so here's for our buzzer. Actually, let's do the environmental sensor. This one actually kind of matters. So they want it to be in an area of low heat. You're gonna have heat over here and noise. Yeah, I think this should have pretty low noise or low heat. And they also have the pin 7 just thrown to a thermal tab. It doesn't actually connect to ground, and I think they explicitly say actually not to. So we can just set it there. And they were also pretty adamant about not wanting any components nearby other than the decoupling cap, which you gotta love when they put the power and ground pin on opposite sides. So maybe like that. Actually, no, let's do this. And then our ground path is somewhere in there, but we can worry about that after. God, this is a really poorly laid out chip. The I squared C on opposite sides too. So SCL goes on there. So if we route around on the top side, that works. And how I said east and west top layer, obviously you can only do so much. There's going to be times you have to jump layers, but you just kind of try to minimize it. So there's our I square or SCL, and now SDA, and we can pop that like that. Okay, and what else is on I squared C? Oh, or pull-ups. Yeah, pull-ups might help. So let's do this. Yeah, Joey, so KiCad does like minor and major revisions, and the KiCad 6 is the next major revision. It's been in the works for, I don't know, what do you say, guys, like 2 years, I guess? And it has some pretty substantial improvements over KiCad 5. But I would say compared KiCad 4 to 5 made KiCad usable in like a work environment. So going from 5 to 6, in my mind, I don't think is going to be nearly as a significant change. I could be wrong though. I haven't messed with it that much yet. So now we can have our pull-ups. Actually, no, let's put our pull-ups down here because we're right by the 3v3 rail. And that makes way more sense than bringing a 3v3 trace solely for that. How did you learn? Find a project that you want to do. I hate tutorials that go into like an academic sense when you're getting into something and like teach you individual skills. I learn way better by being like thrown to the wolves and be like, I want to build this thing and just struggle and kind of figure out how to build it. And if that's the case, Google for any questions you inevitably have, and Stack Exchange will be your best friend. But yeah, find something you want to build. It doesn't matter if you think it's too hard unless it's like crazy. Just find something you want to build and go with it. I mean, honestly, that's my advice. So now Q4, this is the photo transistor. This detects when it's dark in the room, so we can turn off the screen. This really doesn't matter where it goes, so I guess we can just hold off on it. So now the environmental sensor is done. So what we can do is add a keep out here. Man, this is just such a poorly laid out chip because we need to have a copper pour under the I squared C because you have to have a return path for the I squared C, but they route it on opposite sides. So maybe let's rotate it and make it a little bit smaller of an area. That's something that's definitely annoying, is when your layout gets so dictated by how the chip designer wanted it to be, and so often it just doesn't make sense. So maybe we do something like this. Like that. And now if we have power coming in somewhere over here. And now this, why are we on the top layer still? Because we need to get ground over to here. So yeah, this is another one of those cases where you can go against trying to keep all of the top and bottom layers north-south versus east-west, just because it doesn't make sense to sacrifice your layout too much. Okay, so now ground gets there, 3v3 here. So now to do our keep out, let me think. Actually, you know what I think we should do is let's make a new. Man, this is a tough one because we need to have the I squared C. So maybe let's do this. Maybe let's do a keep out for copper pores, and we can do it just on the top layer. Yeah, this actually won't be that hard. I was overthinking that. If we just do a keep out here for the top layer, I'll move that. that should keep most of that heat from coming over, at least where it's touching the chip. And then we'll obviously tap into ground, and I believe that should work. Come back and change that. Okay, so that keeps this chip a little bit cooler. Now, next we have, this is for the enable pin. So yeah, I guess we can do the this whole mess. And now these we can move down to free up the bottom layer some. Yeah, luckily I got out of Eagle like literally just by chance. I believe that timing was KiCad 5 was released, and then like a few months later is when Eagle pulled their Eagle move and went with Autodesk. So I never had to put up with any of those changes, fortunately. Okay, so I squared C is good. Oh, of course, that IO pin is right there, so I should have not done that yet. Okay, so this is kind of a cluster, so let me make sure at least all of the passives are lumped over here. And yeah, it's such a weird programming scheme that the ESP32, I saw some dev words with milling line. Yes, exactly. And that is a good option, is you can put a routed slot through here to help any heat from getting over here. And then again, that's just what's so stupid how bad this layout is, because if you were to do that, you would ideally just have one entrance to that area. Obviously, you need tabs to hold it, but you would have your copper come in here and have your 3v3 here. But the fact that these are all on different sides, it makes that really inconvenient. But yes, totally, putting a slot here would be significantly better than this. But I don't care about it being super accurate. I just want to know if like our dehumidifier broke and we're gonna lose a lot of very expensive components. So I don't care if it's a couple percent off. So I have no idea how this route is going to work. They have such a weird programming scheme with these ESPs. I mean, in their defense, it does work quite well when it's set up, but when they could have just used like a JTAG or an ICSP, I think I would have just gone with that. What sensor did I decide to use? I have no idea. HDC 1080, of course. There's tons of them on DigiKey. Again, I don't need anything super accurate, so it really doesn't matter for me. Ooh, this is getting ugly. Again, I don't care how it looks the first time I do a route, because I find that the more time you spend trying to make it look pretty the first time, you're never going to, it's always going to save time by just doing it quickly, at least for me, because I'm not good enough to see all of the routes in advance. It's easier for me to just figure it out after the fact. Oh, kind of off topic. Has anybody here tried the new Raspberry Pi microcontroller? I know they were out of stock for a really long time, or their lead times were really long. I don't know if that's still bad or not. Yeah, I'm gonna get rid of this switch. I don't need to reset it. There's not gonna be space. But yeah, that Raspberry Pi, I really haven't looked into it. I just thought it was kind of interesting that they would have done it. I think that chip has the wrong pinout. Oh, well that would explain it. Alright, well let's check. That would certainly explain some things. Oh, good catch. Well played. Well, I take back what I said. It is not as bad of a layout as I thought. Okay, so let me change on the schematic. Man, how did I mess that up? I guess when it's not for a job for work, you kind of get lazy on double checking. Oh, I was right there. Okay. Okay, so 1 is SDA, 2 is ground, 3 and 4 are NC. Uh, 5 is power, 6 is SCL, 7 is non-C, which is the thermal. Sweet. Yes, the data sheet does mention those slots. I saw that earlier. Yeah, I mean, depending on how much time when everything else gets finished, we can totally do that as well. Okay, so now... Okay, so now I changed schematic, SCL, SDA, NC. Sometimes you have to do that to keep KiCad happy, I kind of forget. Yeah, what I saw with the Raspberry Pi, it just seemed super cool that they had the true PGA pins, like the programmable gate arrays, so you can kind of make them whatever you want. But outside of that, it didn't seem super interesting, but it does seem cool though. I mean, for something that cheap to have that, that's pretty rare. You don't see that very often. But it does seem like Raspberry Pi, the reason they did that is obviously so they can work on the chip manufacturing in-house on their silicone, which if they have something else coming up, that's pretty cool. Okay, so SDA, SCL, so maybe now, yeah, now just for the way this has to be positioned, it's a little inconvenient having to have the 3v3 over on this side, but it should be fine. But good catch on that pinout. I do not think I was planning on double checking the pinouts, so that would have certainly made this first revision have to have some rework. Okay, so that is sorted. Now I guess go back to this mess. Okay, so maybe we put the reset over here. Oh man, that is really ugly. Okay, TX out should be pretty easy. Pop that there. What does this need? Oh, that needs there. Yeah, that's not gonna work. People are speculating the second one. Yeah, but it doesn't have a later complete version of the board. Yeah, that'd be pretty cool. And if they could beat the ESP on price. I mean, I highly doubt it, but if they could do that, that would be pretty solid. I'd be pretty impressed with that. Okay, I'm gonna start over on this. This is terrible. Okay, let's think about this a little bit. I think ultimately Q2 probably goes here because Q1 maybe we flip-flop because enable is there, so we can route enable up and over. Yeah, now let's move these over. License, commercial. Oh. Yeah, I honestly have no idea the licensing side. Oh gosh. Definitely where KiCad is very weak is pad entries and then their interactive router for stuff like this. It's pretty weak. Oh, for sure, the ESP would be more powerful, but depending on the price that they can pull off with how cheap that new Pi is, I think that's where they could have a decent shot. Okay. Oh, right. Why is it that every time when there's an option for having to crisscross traces, it seems like 100% of the time you end up having to crisscross traces? Hey, how dark is my camera? It's getting really dark in here. I need to get better lighting. All the lighting in this office is fluorescent, so it makes the camera look like absolute crap if it's running while filming, because you get that like weird flicker. Out back where the assembly line is, that's all LED lights, so that is a heck of a lot better. Okay, so let's try this now. Papa Via. Because for like something like this, if you could get that little Pi, I mean, I guess it's fine. But for something like this where you just don't need it, I mean, you're talking over I squared C, and then if you just had a simple Wi-Fi stack, that would be pretty nice. Okay, now what does this connect to? Maybe let's wait on that side. Okay, RTS can find its way over here somehow. This maybe goes like that. And this silk screen is not how the connector is. I don't have one. It's actually up in here, so we can go a lot closer than what the silk screen implies. So that's good, that's good. Yeah, I think this looks a lot better. So TX and RX first. No, because we're gonna need to do that the other side. Ah, that would be nice if it let you do that. Why am I using the module instead of bare chip? Because it's easy. I mean, yeah, certification's nice, but I mean, this is just something that's going in our office here. But yeah, I mean, I don't want to do like an antenna design for something like this. So industry-wise, the number that you see thrown around is, what is it? It's either 25 or 35,000 units a year. So if you're doing any lower than that, it typically doesn't make sense to do your own either Wi-Fi or Bluetooth antenna, and you're better off just using the pre-certified modules. If you're doing more than that per year, then it makes sense to do the upfront cost of certification in the design. The design's not the hard part, it's getting certified because it's really expensive. But anything other than that, it typically makes sense to just do a pre-certified module like this. Okay, ground is good. So now we can take leave this up and, oh wait, no, this one. What is this? Oh, there was still one more. Okay, so that is just our 3v3 rail. What is D2? Oh, yeah, I already talked about that. A TVS diode for ESD protection. Our problem here is getting the 3v3 specifically to this is going to be a pain because it's out of the way. But that should be fine. Now here, pop this one up. And then IO0. So here's a pretty good example of where the north and south, east, west comes in handy, is since all of these are roughly north and south traces, it made it so I was able to dodge these traces really easily, where if you were just kind of going in any sort of order, it would have made that a lot harder. Okay, so that, just one last trace here. Oh no, one more. So this one, maybe up here. Okay, that seems reasonable. Obviously some more time could easily clean this up better, but they're low speed traces. Reset. They're low speed traces, they don't carry much current, and they're only used when programming. They're obviously some of the lower priority, but it's just there's a lot here. Now where are these? Oh, these are test points. I don't know if test points are going to be going on. Or at least maybe do surface mount and throw them on the backside. But why such a strange connector? It goes to a touchscreen with a ribbon cable. Unfortunately, I do not control the connector they use. Okay, why is that angry? Oh, that SCL trace. Okay, yeah, we'll worry about grounds in a little bit when we're done with this. Okay, so now for the buzzer, this is just our low side FET to switch it on. I think we have a gate resistor, yes. And don't worry about asking, it gives me something to talk about while I'm just silently routing stuff away. Oh, the programming one. Yeah, that would probably make more sense. I'm sorry, I wish I had one of those cables here. They're called tag connect cables. Here, give me a sec. You're not the only one who's asked that. Oh, wait. So Tag Connect, super old school website, but these are the ones that I am using, but the six pin version. So basically, they have these little clamp on dealios to where when you push the connector and it grabs and holds it, but you can also get them without those. So, and this is what someone else brought up. If you don't want these big things here, you can get the footprint without them, and then you just get the cable that doesn't have those legs. The problem is you have to hold it. So it's super good for like after the prototype stage, but after the prototype stage, you probably have a functional tester with a built-in programmer. But yeah, either or, they're great. Whoops, what is that for? Oh, this is for the photo transistor. Okay, so I believe a live stream like this doing BGA fan out. Oh boy, I am not gonna be the right person to do the BGA fan out. BGAs, I definitely don't have a lot of experience with layout wise. Our layout guy, he does all of our BGA stuff. I've wanted to have him, I want him to do one of his layouts and record it because he is by far the best person I've ever seen. It's like almost scary, like watching the stuff that he can get done. Because the problem with a lot of this stuff is it's like literally art, and I am not a very artistic person. So that's why I like the schematic side a lot more that holds the clipless. I did hear about that. That they make one, it clips on the back side. Yes, I'm glad you brought that up. I've never used one. But again, if I don't have to worry about the space as a huge issue, then why bother? So yeah, this is such a pain. This 3v3 solely a pull up for the programming pin. It's the only 3v3 rail over here. And it's the only thing it's the thing that's gonna mess this whole area up. I'm sure I'm missing something that I'll see in a bit, but for now we can just throw this on. I love this format. Are you gonna stream off? And so, what actually brought up doing this stream, I don't know how many of you guys are on the Discord channel, but I was getting ready to film this, and I actually started like 10 minutes of it or something, and filming layouts is the most difficult, time-consuming thing ever, because it takes so long editing if you're going to cut it. So I basically asked on Discord, like, is this a format you would like, or what are other suggestions? And people seem to like this. So yes, I absolutely want to do this more often because it is so much easier for me. I just do the layout and get to talk about it, and I don't have to spend 6 hours editing. So yeah, I mean, if you guys are, come on, if you guys are a fan of this, I totally think something moving forward would be I do the schematic and like overview videos like the way I've been, and then do all the layouts like this, just because again it saves so much time, and if you're not able to watch it live, it stays up, which is pretty cool. So yeah, definitely give me feedback on what your guys' thoughts are with it. Okay, so that's pretty much all the important stuff routed. Test points, we've got ground, so I guess let's do the thermistor or the light sensor, photo transistor. So this is going to mount like that. I guess it really doesn't matter where it goes. I guess it really doesn't matter where it goes, because anywhere I'm gonna have to solder something onto it and then just run the wire. So I really don't think that matters. Awesome. I'm glad you like that. it saves me a lot of time. So maybe this goes, I don't know. This really doesn't matter. Maybe just like dead center in there. And now here's the resistor for the divider. Oh yeah, and then it gives us a nice spot. I've heard that the number, oh yeah, totally. When you start getting into BGA fanouts, that's when layer counts become a massive importance, and not only the number of layers, but if you can use blind vias or micro vias, that saves a ton. But again, the BGA side, I don't even want to give a ton of insight on it because honestly, that again is not my forte. I've only laid out like 4x whatevers before. I've never laid out like a true big BGA. Maybe one day, but again, our layout guy, he's so good at that stuff. Maybe just leave it to him. Okay, so now, I guess drop a via here. And this should be bottom layer. Oh, and as a heads up, again, I mentioned this on the Discord, the next big project that I'm working on, it'll be by far the biggest project I've done on the channel, is a USB hub, most likely a 1 upstream, 4 downstream with it's going to have a Type-C input, Type-A outputs, and it's going to be presumably super speed or super speed plus. I'm not sure on the specifics yet, but I'll be posting the intro video on that soon, so definitely be on the lookout for it. And if any of you guys are yes, Jeremy, that that will definitely make it a lot better. If they add fan out tools, they have Gary, our layout guy, he said they had a plugin for it that he messed with. He has a knack of finding all of the really cool plugins, but then never ends up using them. But yeah, when that's natively supported, when stitching vias are natively supported, that's another plugin. Stuff like that. But what's cool so far, it seems like with KiCad, the majority of the features that they're missing are really quality of life stuff, not like anything super crucial, at least not that apparent. Okay, so 5 volt has to go here. That's obviously going to have to be a bottom layer, so we can do this. And again, my power traces certainly are not final. I'm just trying to do that to get everything out. So let's manually do this for now. We can pop a via, and then 3v3. Maybe let's get rid of this via and tie it straight into here. Okay, what else do we have? Grounds. Let's get rid of the test points for now. Yeah, I assume it's not very good. Okay, what else do we have other than unconnects? Courtyard. Oh, that is barely. Okay, let's see now. I love how the second part of the entire layout I placed had a courtyard violation, go figure. Glad you made it. Okay. Okay, sweet. So no problem. So now with, and obviously there's non-connects, but that's what I'm going to get to now. So one thing that I like doing if it's this stack up or a similar one, and again, but that would kill your pick and place. Yeah, no kidding. Um, so the stack up is signal and power, ground, and then your dielectric, then ground, signal, and power. So I like having the ground. Is the ERC good? No, it's not that good. That's something they're improving in KiCad 6 a lot, and there's no like customizability with it. It kind of is what it is, but it's supposed to be pretty good in KiCad 6. So I have a ground layer on the top plane. I do that just because it can lower the impedance when you have stitching vias, but it shouldn't be relied on as your main reference plane. So what I do is, now that the layout's, roughly done, I still want to go back, and there's, I'm sure, quite a few places that can be improved. What I will do now is take the top layer and either move it away or just delete it so the top plane is gone. And now you see where all of your grounds are, and you need to explicitly throw them in a via. And this essentially forces you to make sure that you have a good reference point for your vias to attach. Yes, totally. Yeah, I like teaching, and I like talking about things, but only if it's things that I would feel comfortable doing if it was like a client's job or something for work. So now these, and this is another annoying thing with KiCad, since these are technically separate pads, you have to connect all of them or else it'll give you a DRC warning. But again, it's just quality of life stuff. That's where, like, if you use Altium, or not OrCAD, I don't like OrCAD, but if you use, Altium's kind of the gold standard for semi-affordable pro layout tools, is there's just a lot more quality of life stuff. The actual functionality, unless you're doing high speed, KiCad's definitely not good for high speed, but for just standard stuff like this, it works pretty well. Okay, and I'm sure someone's gonna comment how I'm doing this the absolute slowest way. Yeah, I heard about that too. And the back annotating, which I am really looking forward to, where you can annotate from the, or you can do two things. You can annotate location-wise from the layout. So left to right, it'll redo Q1, Q2, Q3. And then you can also change a trace based on what pin it should go to, and it'll update on the schematic. You can do it now with like the back thing, but it doesn't really work well. So now this side's pretty important because these are your decoupling caps, and you want to have the ability for your decoupling caps to get to your ground layer in as direct of a way as possible. So typically that entails just throwing a via wherever you can. Now this via, another thing that there's a lot of conflicting opinions, this technically increases the impedance between the ground getting to here. If it doesn't matter that much, I certainly don't know. There's a lot of different opinions. What I typically do is, as long as we have our ground via here, that means that this loop is able to circulate underneath this and pop up on the other side as well. And I think that impedance will matter more. But if not, it can just go on the angular ring. So there's that, and now we can do the same thing over here. And even if you're doing like a 2-layer board, having forcing yourself to do the traces for your ground reference is always a good idea, because it forces you to know where your grounds actually connect to. If you don't, you're just making an assumption of where your return paths will be, and it's never a good idea, especially with grounding, to have to assume, because that's how you can have a lot of issues in EMI. So I'm trying to get this to where I can put another via here. Have you heard any better systems? Okay, so my programming experience, actually, that was the first thing I ever did, like electronics wise or any of this stuff. I was actually really big into programming back when I was younger. That's what got me on the path of engineering in general. I did a lot of Pascal and Delphi when I started. Then I did some Python, or actually I did a lot of Java beforehand. And then decent bit of Python, and then obviously now in the embedded systems world, the last 3-4 years, primarily C, but again, that is definitely, oh gosh, that's ugly. Actually, I guess that works out. See, and this is another thing with KiCad, is it does not have good escapes from traces. But now I definitely do not do that much programming. We have a couple firmware guys who handle that side. I'll still do like script stuff with Python, but C, just like code review stuff, not actually any formal programming. Okay. Yeah, you can. I mean, the via in and of itself isn't going to help, or won't help, but having a actual ground trace in between certainly will. Which one are you referencing? Clock and data are set? Yeah, I mean, the data side for the programmer, I mean, that's only for programming, so that wouldn't be a huge deal, and I squared C is pretty slow. But yeah, I mean, that certainly can help. Okay, so now ground. Now this is again where it matters, actually more so here. Let me work on this side. So here, coming from the common mode choke, I will put a few vias here. And same with on every trace, because again, the name of the game with your reference signals for decoupling caps for anything like that is lowering the impedance, and the more places you can have this connected, the better. And if you really want to lower your impedance and lower your loop, you put your vias in the center, but that gets close to being a via in pad, which is not pleasant unless you want to have them plated. So what you can do, and what's the coolest project you ever worked on? I'll get to that in a second. So what you can do on, really don't have a good example here, but if we had a separate power plane, we could put our two vias right up next to each other like this. So then your circular loop is a lot smaller, and it can actually reduce the impedance of your decoupling caps by a significant amount. And that's another thing, like some of the decoupling. I really want to do some videos on that, but I'm still trying to figure out the best way to show it without just doing SPICE simulations, because SPICE is cool and it's 100% accurate to your model. So if you don't have a great model, which modeling trace inductances is really hard, you're not going to have a super accurate model. So I really want to get a way to do it with an actual board. One day I'll figure it out. I wish I had like a actual EMI testing lab to be able to do radiated emissions. Maybe one day. Which stackup are you using? Top and bottom are power and signal, and inner layers are ground. Okay, is that everything? Coolest project I've ever worked on. Work-wise, the coolest ones I can't really talk too much about. Personal-wise, the project that I was at when I was at school, I missed one. Where? Oh, it's because the pour? No, 3v3. I have no idea. Oh, okay. I was gonna say. When I was at school, I volunteered. I was in a club for NSL, which is the NASA student launch, and we did rocket launches for different. They would do like a different theme each time. So the year that I did it, the rocket had to go up. You got scored on how close it got to a mile, and then it ejected a lander, and that lander had a downward facing camera, and it had to identify 3 different colored tarps, and whoever could get closest to the mile mark and identify the tarps would win. Super fun. Multiple all-nighters getting it all set up, and unfortunately I wasn't even able to go to the launch. It was in Huntsville, Alabama, and I was in one of my best friend's weddings in Texas, of all places, so I was not there. And even more unfortunately, the planners at NASA, in their infinite wisdom, they put in the manual that you have to be prepared to have your battery systems last for 2 hours on the launch pad. There were delays, and our team was on the launch pad for 4 hours. So every single battery died. We didn't get a single picture of anything up there. And I think only one team actually was able to even deploy because everyone's batteries died. So the end result was pretty terrible, but it was fun. Okay, so now DRC is clean. So now, as is, we do not have any pour on the top layer, but like I said earlier, I do like to have that. So I will go here and put it on our top layer. So now we have 4 layers, 4 pours on all 4 layers. So that is the general. Oh gosh. What is coolest project? Personal project. Kind of. It's for the office, or it's for the assembly line out back. For our part storage, we can't have the humidity get above 60%. So we have a massive dehumidifier and 3 ACs. And I'm always paranoid when there's bad weather that I'm going to come back to find out that one of the dehumidifiers shut off. So this humidity sensor will mount up against the wall, and we can view it, and then it'll connect over Wi-Fi to a server or something, so we can see real time and get notified if anything shuts off. Solid or liquid fuel. So we had a liquid fuel team on a different rocket. This was solid fuel. Yeah, good guess. Yeah, the liquid fuel team. It started when a kid was there, and his dad. It was before my time. His dad was like big into it and had like a full lab set up. And when I got there, they pretty much ditched it and didn't really work on it, so never really got off the ground. Okay, so yeah, now the traces are pretty much routed. Now it's a mix between going through and seeing what you can improve and widening the traces and doing the final route. So honestly, looking at this, I actually, shockingly, don't see a ton that I would change. This is a total mess, but I don't think that makes a ton of sense to really spend much time on it because, again, it's just for the programming side. So we can work on the moat section here. Is the stream like blurry? I'm looking at like the preview window and it looks like super blurry, but I think that's just because I'm on the preview side. Okay, so to give this 3v3, I want to have all of the return signals come from over here. So what we can do is route the 3v3 over there. Looks fine. Okay, sweet. Okay, so let's do 3v3 on this side. Okay, so the key with this is, since I am going to make a full cutout here, or mostly full cutout, I want to have the grounds connected at a single point, and that single point has to be where all the return signals are coming from, or else you're going to have a massive ground loop, because if we had, say, no ground anywhere on here, and it was just coming from here, but our I squared C crossed over where there's no ground, any of those high frequency harmonics, or I don't know what speed this will be clocked at, but even the fundamental frequency, it wants to go back in the path of least inductance or lowest impedance, which at high frequencies is the lowest inductance, which is directly under the trace. So it wants to go from here to this, and then on your ground pour underneath the traces right back to the chip. If you force it to then go around here, you are making essentially an antenna that will radiate around here. So if we make this an isolated plane, we have to have it be where those traces are. So does anyone know KiCad? To do a slot, I typically will just use a random layer and then just tell the fab that that's a 2mm slot, like if I'm doing routed tabs for panels. Does anyone know KiCad have a better way somewhere that I'm not familiar of? Because what I would do is use like the comments layer, make this 2mm. 2mm is obviously way too much. Maybe do. Can you do? But what if it's a? But Jeremy, what if I'm trying to do like an actual slot? No, because so what, you're saying like a rectangular, so just do like a box here, or are you saying just do the edge? You just place an edge cut wherever I want the cut. Okay. Just for it being easier to see, I am going to just do this, but I don't doubt that you can do something like that. But it'll be harder to show. So what we can do for use it for breakaways, yeah. No, I don't doubt you. I'm sure that works. That's funny you use that for your breakaway tabs. I always just do something like this. So the goal with this is to just have as little of copper mass here. And the rule of thumb on breakaway tabs is you want to have around 10mm. You can do curve with edge cuts. Does it show up on the, if I did that, does it show up on the 3D model? That'd be cool. Let me try that. No, it does not like that. Because yeah, it would need it to be a closed shape for it to show on the 3D modeler, or the 3D displayer. Okay, so for this, we can do something like this. So now, wherever you see blue, there will be a 0.5mm draw a box. Oh, draw a box. Oh yeah, because you can do it with a circle. Yeah, because this is just like if it's a slot. So, I mean, if it's a, oh gosh, don't exit that. Okay, yes, so that does work. Okay. Okay, but it won't have the rounded edge, which I guess is fine for now. And I'm sure Jeremy is going to tell me all about how I'm doing it wrong still. I'm currently applying to college and submitted system looks pretty cool. Do you think it's a good career choice? I mean, if you like this kind of stuff, pay, yeah, I mean, it can be pretty fantastic depending on what specific industry you're in. But don't do a job for the pay, obviously. But yeah, I mean, I think it's a really good career choice. It's not going away anytime soon, and there's typically a lot of jobs out there for it. Oh, it still didn't like it? Dang it. Okay, obviously that endpoint is not fully closed. Okay, I'm not going to waste any more time on that. Alright, so I'll just do a simple box just so it can still show it off. Or it can still at least look like it. Okay, so basically, say we want to do our slot like to here. And of course, if this is, you're not doing exactly, okay, so this is how you do it, got it. So they would just make the round part there. Fantastic. But yeah, obviously you're going to want to do this in a more accurate way and kind of measure it. But for now, it doesn't really matter. So there's our 2 slots, and maybe let's do... Yeah, arcing the ends would obviously make more sense, but what Jeremy's point is a fab house, they're going to do their router to this shape anyway, and it obviously ends in an arc, so I don't think it really matters. Okay, there's our beautiful routed slots, and I forgot to update the pores. Okay, so there's our slots here, so now we will not have near as much of an area for the heat to get through here, and we could also do a little slot there. Now you could have the ground continue and go on all edges, but I don't think I want to do that. So what I am going to do, I think, is just block off this area to force there to not be any pores cutting through those slots. So like this, and now what that should do is essentially make the ground just come from here. So now the majority of the heat should be on this area, and since we have slots here and we have no continuous copper, oh, I need to have that be on all layers. So now no copper on any layers can get there, and then our ground can connect from here. That should keep a lot of the, do I need a pour for pin 7? Pin 7, no. So that is just a thermal pad. They explicitly say don't connect it to ground, which is always fun when they say that. So yeah, that should work, and now Alt 3 shortcut for 3D view. Fantastic. I did not know that. Okay. That's the best part, I swear, about doing these videos, is learning all the different stuff, like just little nuances that people have figured out with KiCad that I probably never would. So much of the stuff that I have learned with this is from doing these videos. So now we can add our vias here. Just to fill that section in. Ooh, that's ugly. Okay. 3v3 we don't need anymore. And let's check this. Good. So then obviously you would want to clean this up a bit, make sure all of your angles look decent. And another DRC. Yeah, so everything looks good there. So now do one more check. So like, and this is something, KiCad edge, cut layer, fellows. Yes, totally agree. And I use Fab 3000 as our Gerber checker, and it handles slots amazing. So I typically will just let that handle it and just do whatever on here. So now what is also good is, and I know earlier I said to do the best you can north, south, bottom layer, east, west, top layer. For stuff like this, that doesn't matter, and it's just adding extra vias, even though it goes against what we were trying to do. Just put it all on the top layer. Doesn't make sense to do it just for the sake of keeping it consistent. Yeah, so I think that I don't really see anything obvious that could be improved. So now it's just a matter of cleaning up all the traces and whitening everything, which, as white as you can do it for the most part, is what I typically will do. Start with like 0.5 millimeter on the power traces, and then if you have to, neck them down smaller from there. And doing pores, and I know someone's going to tell me about doing the net classes. I totally know that, but I find it to take longer than individually switching the trace widths. I would like for them to have an easier way to do that. And pad entrances are a really weak point of KiCad. They make this type of stuff really painful. Oh, yeah, what I was going to say. Pores for stuff like this, it depends. A pore for a situation like this is almost always going to be better because you're maximizing the width, so you're going to be inevitably lowering your impedance of that trace. If it's for something like this, where it's just not that big of a deal, I'm not going to spend the time because that's going to easily double, if not triple, the length of the layout. So for stuff like this, I'll just do traces. If it's a high power board or if it's something more important than this, then I will certainly do pores for all of these, especially on the main power traces. Because it's not even so much the current carrying capacity is a wide plane due to the skin effect on any high frequency signals. The impedance will be a lot less if you allow the signal to spread out along it. And not even just the skin effect for high frequency, for low frequency, since it will take still the path of lowest impedance at low frequency, that is resistance. And in order for it to have a low resistance, it has to spread out, which if you have just a single trace, you are obviously not allowing it to do that. But, and I know I'm also skipping these, so I'm getting a double trace underneath them. That's another thing I would certainly try to avoid normally, but for this, it is what it is. This one for 3v3. See what it's attached to. That's a really long connection for the humidity sensor. I do not like that. I'm gonna change that. I mean, I think it would work, but I can much easier just do something over here. And then the next size, go down to like 0.25. Yeah, I mean it does kind of have the group settings, but the problem is, yeah, it just needs a way to switch between those quicker. I think I get what you're saying. So now here we can have this come up and then pop it here. Oh gosh. This is never good. You never want to have a non-reference plane being the farthest exposed on the edge. That can radiate quite a bit, so you want to do what you can to keep it tucked in. And even that actually is still terrible because it's only a one-sided connection, so this needs to be moved down a little bit. And then this, I've seen this as a bug a lot, and they, I guess, fixed it in KiCad 6. It cannot move your trace, but then when you move it back, it doesn't fix itself. So you end up having to undo just to go back to where you were. So that push and shove feature is really weak on here. Okay, there you go. So that's still not ideal. Maybe it would make more sense to take, yeah, let's do that. This would make more sense. So let's take the 3v3, and now of course the trace that I moved to the top layer because I didn't think it needed to, now gets moved right back to the bottom layer. And this is something I don't know if I've shown exactly how I do it. With bigger traces, again, trying to lower the impedance, having double vias. What I like to do is if I'm just doing two, I'll connect it like that. Then I take the top trace and just drag it over. So then, oh, why did it? That probably wouldn't be doing much. Do our bottom layer like that. Now we have our top and bottom connected there, and then do the same here. So it essentially doubles our trace width for that little via connection. And this we can take, I guess, all the way out here. No, because it has to go in the slot. Never mind. Okay, and now, oh, fun. I guess we can move these vias over a little bit. So this is probably something I would reroute a little bit on the I2C lines just to make this a little bit cleaner, but it shouldn't make that big of a difference. There's that. So all those power traces are widened other than going to the enable, so we can redo that a little bit. And ultimately for something like this, because it's not a high current trace at all, it's just a pull-up, it doesn't have to be widened, but if you have the space, I typically try to. Unless you're dealing with high speed, especially like impedance matching, or different impedance match, like differential pairs, the wider it is, usually the better. So if you have the space, you might as well. It's not going to hurt anything, unless you're trying to impedance match, of course. Okay, we can make our ground traces bigger here. Okay, oh, these. Okay, does anyone see anything else that could be improved? I don't like how this trace is over away from here. I feel like ideally this would be swapped over on the inside or the outside. Yeah, let me see. I think that can be improved. Oh, but then this needs 3v3. Can try it. I don't know if this is actually going to help. Okay. Give that a little bit of space. And then, yeah, that actually is quite a bit better, at least for that run. That shortened it up quite a bit. And now 3v3 we can either grab from the right side or the left. Probably makes sense from this side. And since this is, again, a low current trace, we really don't care about the width, but I'll keep it this wide because it doesn't seem to be in the way. And we can just add a via here. Okay. All right. So then obviously, other than doing either having more people take a look at this, if this was like a design we were doing for work, we'd obviously do some formal reviews of it. Another thing that helps is you stop working on it for a day and then come back and look at it. That can help find things that you didn't previously. But otherwise, I believe it is pretty well set. Yeah. So any other questions before I end the stream for tonight? And one thing I will do, I don't know how many of you guys or if all of you are in the Discord channel. I will post the invite link here in a second, because if you guys are not in it, please join. Getting quite a few people. I think we're almost up to like 100 people on it. Gonna be doing some pretty cool stuff on there coming up. But yeah, I hope you guys enjoyed this. Maybe I'll upload this to GitHub, post it up there, and before I do the build, if anyone wants to fix some things with it, do I do any? Yes, I use Fab 3000. I really don't like it. I think it's terrible for what it is, but it's the only one that's even remotely affordable. Gary, who does our layouts, he has a seat of Cam 350 personally to him, so we cross-check. The only reason I keep Fab 3000 is, again, the pricing, and it's nice having two different DRMs to see if they disagree in anything. But no, totally, Cam 350 is by far the best one, unless you go to like really, really high-end tools. But yeah, so I'll post this maybe on GitHub, see if any of you guys want to take a crack at making some changes. And if not, I'll order this up, do a follow-up video, and then we can get it built and see if it works. Alright guys, so I will see you in the next stream or video. I appreciate you guys watching.